In today's modern food world, there's one product almost all of us have come across at least once: canned tuna. At first glance, it's just a small metal can, ordinary and unremarkable. But inside lies the story of an incredible journey, stretching from the depths of the ocean to massive industrial factories, before finally landing on the tables of hundreds of millions of families. Few people realize that producing a single can of tuna firm, flavorful, and packed with nutrients requires the operation of a global machine. It's a system that connects thousands of fishermen, engineers, factory workers, and food experts across the world. And this story begins with the tuna itself, a species often called the jet fighter of the ocean. Tuna are not ordinary fish. They are natural-born athletes with sleek, muscular bodies and stiff fins like turbine blades. Their top speed can reach up to 75 kilometers per hour, comparable to a car cruising down the street. Some individuals can even swim thousands of nautical miles without stopping to rest. Tuna are also one of the rare fish species capable of regulating their body temperature, keeping it higher than the surrounding seawater. This unique trait allows them to maintain strength, speed, and endurance during long chases after prey. Because of this, tuna have long been a terror to smaller fish and squid in the open ocean. But for humans, that same power has turned them into one of the most economically valuable marine resources. The canned tuna industry alone generates tens of billions of dollars each year. Thailand currently accounts for nearly 30% of global tuna processing, while the United States holds the crown as the top consumer. Every year from May to September, the major fishing grounds of the Pacific, Indian, and Atlantic Oceans become more vibrant than ever. This is when massive schools of tuna migrate with the currents, gathering in large groups to hunt. Fishermen call it the golden season, the time they look forward to all year. Modern technology has completely transformed the way humans catch these high-speed fish. On ships weighing thousands of tons, sonar and radar systems continuously scan the ocean surface, searching for signs of tuna schools. Some vessels even carry helicopters, allowing pilots to spot from above and pinpoint bubbling patches of water, the telltale sign of tuna hunting below. Once the target is located, fishermen deploy the most effective method: purse seining. A massive net stretching hundreds of meters long is released to encircle the school. The bottom rope of the net is then tightened, forming a giant bag that traps tens of tons of tuna inside. Within just a few hours, the ocean's fastest swimmers become valuable catches, neatly hauled onto the deck. As soon as tuna are brought on board, they must be handled immediately. Their bodies are warm and muscular, making them prone to rapid spoilage if not chilled right away. Fishermen quickly place them into freezing holds, dropping the temperature to minus 18 degrees Celsius or even lower. From the distant ocean, the frozen tuna are transported directly to port on refrigerated vessels. From there, specialized trucks deliver them to processing plants. Interestingly, tuna are usually kept in their frozen state rather than thawed, in order to preserve the best possible meat quality. At the factory, tuna are stored in massive cold warehouses, with temperatures ranging from minus 18 degrees Celsius to minus 25 degrees Celsius. Under these conditions, they can maintain quality for up to 3 months before processing. The handling of frozen tuna is one of the industry's key secrets to success. Instead of thawing, which can cause dehydration, discoloration, and increase the risk of contamination, the fish are fed directly into industrial cutting machines. These machines, capable of processing tons per hour, use alloy or diamond-coated blades sharp enough to slice through tuna at minus 20 degrees Celsius without cracking the meat. For giant species like yellowfin or big-eye tuna, however, machines must give way to human skill. Expert craftsmen, often referred to as tuna artisans, use specialized knives to separate each cut of meat with precision. This work requires not only strength, but also finesse and years of experience. So much so that a highly skilled cutter can earn up to $200,000 per year. After the initial processing stage, the tuna are placed into industrial steam cookers. Steaming cooks the meat while preserving its natural sweetness and also loosens the texture, making it easier to remove the bones. These massive steamers can handle tons of fish in a single batch with precise temperature control down to each degree. Once the fish are cooked, workers begin the deboning stage, one of the most critical and detail-oriented steps. Using bare hands or thin gloves, they carefully remove bones, skin, and any parts that don't meet quality standards. The risk of sharp bones piercing their hands is constant, but the dexterity of human workers remains something machines can hardly replace. The intact, firm fillets are then neatly arranged into cans, ensuring that when consumers open them, they see beautifully cut pieces of tuna. Smaller fragments of meat, meanwhile, are used to produce shredded tuna, a more affordable and widely popular product line. A can of tuna wouldn't be complete without its preserving liquid. Depending on the market and consumer preference, this can be vegetable oil, brine, or even a special seasoning sauce. This liquid layer not only keeps the tuna moist and prevents oxidation, but also gives the product its distinctive flavor. Once the tuna and liquid are placed inside, high-speed seamers seal the metal lids shut. In just 1 second, a perfectly airtight can is formed, blocking out both air and bacteria. Any defective cans are automatically discarded, leaving no chance for them to slip through. To become a product that can remain safe for years, canned tuna must go through its most demanding stage, high-pressure sterilization. Inside giant retort chambers, the cans are heated to 121 degrees Celsius for 60 to 90 minutes. Under these conditions, bacteria, spoilage enzymes, and even microbial spores are completely destroyed. Afterward, the cans are rapidly cooled with cold water or air, both to preserve the texture of the meat and to ensure the metal cans don't deform. Once everything is complete, the tuna cans are packed into bundles, wrapped in cardboard and shrink film. The packaging is printed with all the essential information: origin, ingredients, and expiration date. Finally, pallets stacked with tens of thousands of cans are wrapped in protective film, loaded into containers, and sent on their way. They cross the oceans once again, but this time, not by swimming. Instead, they rest inside refrigerated containers, making their journey to supermarkets, stores, and kitchens all around the world. Just think about it. A can weighing only a few hundred grams is the result of a journey spanning thousands of kilometers, involving hundreds of people, and combining modern technology with manual labor. It's a true symbol of global connection. Tuna might be caught in the Pacific Ocean, processed in Thailand, packaged in Europe, and finally served at a lunch table in the United States. The story of canned tuna is not just about food. It's a vivid illustration of how humans have learned to harness nature, blending science, technology, and commerce to bring the ocean into everyday life. And each time you open a can of tuna, remember the incredible and far-reaching journey it has taken before reaching your hands.